separate animals and how we work. But the idea for this was, could we make an alien from the movie Aliens work within the rules of biology, right? Within a set world that we understand, can we make this thing function? A couple of things, a couple of trigger warnings. If you haven't figured out by now, we're going to spoil 2 movies. We're going to spoil Alien and Aliens. Probably could have put that earlier. Such a really good property. It's a real shame they didn't make more of them, right? As far as I can tell, they made Alien, then Aliens, and they stopped making them forever. And Disney never made any more.
Never ruined it.
Never made any more. Done. And the other spoiler is I'm going to have lots of photos of lots of cool animals. I think they're cool. There's lots of extreme close-ups. Some of them are quite gross. And there's at least one shot from the movie Alien. You know which one it's going to be. Spoiler. So, we sat down, we watched the movie Alien and Aliens, we pretended it was work somehow. We thought about it, and we came up with what we have as the life cycle of the Xenomorph, the alien from the movie. And just to take us through its biology, we start with an egg. There's these kind of eggs hanging out. They're about, I don't know, 2.5 to 3 feet tall, so about 1 Kathy in height.
And it's dangerous.
And they're dangerous, like a Kathy. They will explode at you violently, like a Kathy. So they kind of hang out, and in the first movie, our brave scientists, who aren't at all idiots, go, oh, that's interesting. And when they get close, it opens up, and this little scurrying, horrible thing flies out of them explosively, latches onto a face we've just heard, sticks something down the throat of the person, and then a couple of days later, falls off, and we're all good, no harm, no foul. However, at some point in the next 24 to 48 hours, the famous chest burster scene happens. The little organism bursts out of its chest, scurries around for a while. I think the wheels thing was the filming. They dragged it on string. Was that what you're going for? Somewhere over there? When they had it scurrying across the ground in quite a comical looking scene in the original movie. And in the original Alien movie, in the next kind of day or two, we end up with these giant, quite badass predators who run around and kill all the people and get really mad. In the second movie, we end up with this alien queen that lays these eggs, and now we have a life cycle. We've got some sort of massive queen that's a lot bigger, that lays eggs, that produces kind of little things that make either our workers, our warriors, our drones, if you will, or maybe one queen every now and then. Just for a bit of a deep dive into the internet's lore, which was quite a thing to go through. There is way too much lore on the internet about this, by the way. This is my kind of breakdown of what they look like, if we're not sure. So the creature itself is bigger than a person. That's going to come back to us. They're about 2.5 meters tall. Poor Chad here. He looks like a Chad, doesn't he? Poor Chad here is going to be in trouble in this moment in time. And then we've got these little chest burster things that are, depending on who you ask on the internet, about 30 centimeters, 60 centimeters long. Again, maybe depending if they're unraveled or curled up in a ball, because they've got quite long little tails. And so we've got 4 problems I wanted to address, like within the rules of science. These are my 4 problems tonight. First one, you've got one alien in the first movie. How do you get lots of aliens from one? How does that work? Second one, and this is the big one for me. This is the one where physics and physiology breaks down. How did it get so big so quick? That's a problem that we have to deal with. One of the most famous things about the aliens and all their kind of properties is every time they get injured, they bleed fluorescent green blood, which we've brought with us tonight. Good job with the dangerous blood there. Not very now.
More.
Yep. And that blood is highly acidic. It melts through steel, it melts through flesh, it destroys things. So we're going to have a look at that. How fun is that? And then the final one is what the actual fuck, excuse my language, is their problem? Why are they so angry? What's going on there? And so we'll have a look at that too, as our final point. And so the first thing is reproduction. You know, how does one make many? Well, unlike, say, reproduction that we're familiar with in mammals, for example, we get male, female, make baby, and reproduce species over time. We've got this problem where we started with one. And that seems a little off at first. One egg implanted one person into one like little larvae thing, that chest burst out, and then somehow that's going to make more. That's not a very successful strategy, right? So we had a think about this. We had an argument about it, how you could do this. And there is lots of parallels for this in nature, actually. There's a few people nodding when I'm saying this already, so as a teaser, what am I thinking of? What's my example? Someone tell me.
Mama crabs?
Sorry, what was that on the corner?
Mama crabs? Marbled crayfish.
Oh, cool. I like that one. What was your one?
Stick insects.
Stick insects. This one as well. There's lots of.
Chicken in the egg.
Someone had to say it. There's lots of examples of species that have flexible expression of male or female at different moments in time, depending on the environment they find themselves in, depending on the resources available, depending on temperature in some situations. The one I came to, when I was thinking about the structure, with one breeder, with lots of workers, that may or may not be male or female, if you're curious. The description here, I was informed reliably, without gender stereotyping my aliens at all, is the male was working the barbecue and the female was drinking the cocktail. I'd like to say I like cocktails, thank you.
I like barbecue.
Yeah, well, fair enough. Is we came up with these guys. One of the most obvious ones we found immediately was bees. So bees have this really weird structure to the way they organize their societies, which is very different to what we have. People know the phrase queen bee, right? And so what you have in bee colonies is you have a single egg-laying queen who's morphologically completely different to the other ones. She's bigger, she's optimized for laying eggs, up to thousands of eggs per day, which is just insane. Doesn't need to be fertilized to do it. She will produce eggs and lay them. But if a male bee is available and fertilizes her, then she can produce female eggs from that. And now we can get genetic diversity in our colony and we can get males and females coming out. If she's not fertilized, those unfertilized eggs become male bees, which is a useful adaptation because now she has males to make more females, and now she can grow her colony. She expresses pheromones like crazy, which has this really powerful effect on other females in her colony to stop them reproducing, to stop them becoming a queen and challenging her. So she is the dominant one. She is in charge. She has this massive workforce of drones that will gather resources for her, that will work for her, that will do what's needed to make her colony better, to make her children, her offspring, do best. That immortal genome passes down from her line. We're not immortal, but our genes are, right? And that powerful drive to reproduce in this situation is completely different to what we're used to. And it's a really cool analogy. So not only is this setup, plausible, it actually already happens on the world today. Oh, that's kind of cool, I guess, but they're just bees. They're just little tiny things that, piss you off and sting you every now and then. And in fact, their reproduction is so bizarre, and I can't take credit for this joke because Kathy's used it in the past and before, but when the male bees mate with the female queen, their finish is so enthusiastic, they actually blow themselves apart doing it. They end themselves to reproduce and mate with that queen, which is such a great understanding of the male mindset. And I say that as a man, that they are so determined to get this done. But that's cool. So you can have this bee-like structure, this colony, drop one egg on a planet, produces an alien, maybe that becomes a queen, starts laying eggs like crazy if there's resources available for her to consume. And those eggs can become males, which can then fertilize her, which can make males and females. Now we've got a successful colony expanding like crazy, consuming resources like crazy in a non-sustainable way. It has nothing to do with this talk, but in the deep, deep lore of this series, one of the theories is that these alien things were created as bioweapons, drop on a planet and wipe out life before the thing that created them comes along, after they've all died out of starvation, and then repopulates and moves on. So that could work. But again, bees, little tiny things, that doesn't work for us, right? Like, we're big, complicated mammals, we're not just silly little insects. No. This delightful guy.
Oh, they got your gate signed.
It's a much more safe work joke than you cracked earlier. Anyone know what this guy is? Naked Mora. I appreciate the specificity. It is really, really cool for so many reasons biologically. Naked because it has no hair. Mole lives on the ground. Rat is about the size of a rat, but it's neither a mole nor a rat. It's kind of complicated little thing. They're insane. They're crazy forms of life. There's a colony at London Zoo that we study like crazy in my research world, which is how humans grow old and age and what's happening. Because they don't age what we would think right, almost everything ages and gets worse with time. And naked morats just kind of hang out and get older and older and older and do their own thing. They don't get weaker with age. They're really resistant to cancer. They're really resistant to change with time. They live for 20-some years, best case scenario. We don't know how long the longest one lived for, because it lived in the wild, and every year the scientists went back and said, there she is. And they went away, and they came back and went, there she is. And they went away and they came back, and they looked in her burrow, because they live underground, and it wasn't there. Went, oh, maybe she died, maybe she moved. That was it. It was in the late 20s, I think. So these are insane creatures. Ugly as all sin, let's be honest.
What do they die of?
That's a really cool segue off this one, absolutely. But they die of predation. They die of being stood on by other creatures that are underground. That's a ridiculous idea. But they also die of just chance and luck. So even biologically immortal things that don't die of aging-related things still die as you have strokes and heart attacks or get stood on or something eats you. So bad traumatic events still happen to us. They have an insect-like social structure. They have a single queen who dominates, and she is the queen of the colony, same terminology. She keeps a harem of males. That's actually what we decided to call it, a harem of men that serve her and breed with her, and she selects the best from her colony, the best men. She picks them. She physically, violently suppresses any females that challenge her. She is the dominant lady in this colony, and she uses brute force alone. She is a warrior. She is in charge. She grows bigger, substantially bigger, like the queen bee, to better function, to better reproduce, to better dominate, but also to better carry multiple litters per year. It involves elongating her spine and changing her structure and just really, really uncomfortable, horrible things. But that means she can have multiple litters a year of the best men and produce lots and lots and lots of baby naked mole rats to then build her colony. And over time, the colony might outgrow supply and one will move off, and out of her reach can become a new breeding queen at the end of it all. Pizza delivery?
Really sorry about that.
Can I get one too? What's Oh, yes. I was going to say, one of the rules I always tell people about climate science is you have to be able to hold a drink in your hand when you give a talk. I never thought about holding a piece of pizza, but I'm willing to give it a go.
I'm not.
Good answer. They're also really... They're also really, really weird in their structure. They farm their environments in the same kind of way that bees know where to go and they can return to good flowers. These things, they eat the roots of tubers and plants around them, but they don't eat them all. They eat a little bit and let it regrow. And they almost harvest them, like they crop them, so they have sustainable farming of their environment. It's really, really crazy things. This is a queen. This is a normal naked mole rat. So they are really interesting, weird little creatures in so many ways, let alone the whole social structure that's more like insects than mammals. They have a thing that works for them, more power to them, you know? Successful strategy. Evolution doesn't take one pathway. It doesn't even take the best pathway, it takes the pathway that works, you know? And if it works, it keeps going. If it doesn't keep going. Ultimately, Darwin is brutal about this. So that's cool. So, like, the reproduction model from those two little movies not only is plausible, we have models of it working, you know? It's crazy. So that's tick. Now, the big one. How does it go from we to a weapon of mass destruction in just 24 hours? Because that is most commonly cited as a flaw in this movie. How does something get from, you know, the size of your school ruler to bigger than me in a very brief period of time? Just a reminder, so this is what they look like. This is our alien. This is Chad. He's about to have a bad day. And he's going to have a bad day because at some point he's going to get eaten or this guy's going to burst out of his chest. Oh, I forgot a really cool example of why I'm carrying carrots.
Oh yeah.
Do you want to know? Oh, chest bursting scene. There's a really common issue with it. Actually, no, I've got to post music later.
Yeah.
Carrots. Spoiler.
Ooh.
So this is a problem. This to this, but this is smaller than this, right? I think we can all accept that. This is bigger than this, and this can't just magically turn into this overnight. You can't just create mass from nowhere. You need to feed, to eat, to take on things from your environment, and to use them in some functional way. We do it, we eat McDonald's, we drink beer, we get slightly bigger guts. But that happens, to me at least, over years to decades, right? It doesn't happen quickly, unless you really go down that buffet. So that's the question we've got. How do they get so big so quick? How do they gain so much mass so fast? And where does this energy come from? This is a diagram that causes my undergrad students as much horror as this movie causes me when I watch it. It's a really, really simplified example of an energy pathway, a metabolism pathway in humans, and I broke it down to just the basics. We take glucose, and we have two ways we can use it, basically speaking. We can use it anaerobically, produces this thing called ATP, or energy, that's cool. Or we can use it aerobically, and then we can get ATP from that as well, with us so far. If we do it anaerobically, we can get energy really, really fast, but at the expense we don't get as much energy, we get very little in the grand scheme of things, and it produces a byproduct of acid in our muscles, in our body. That thing we hear called lactic acid, right? Lots of little hydrogen ions floating around, creating acidity in the liquid parts of your body and causing pain and stopping things from working and causing real problems. If we can push it through this oxidative pathway, use oxygen to combine with that glucose, we can use this whole complicated thing called Krebs cycle, which really causes my students horror. No one remembers that from their student days. They memorize that thing. And we get heaps more energy. Instead of 2 energies, we get 30, 32 energies, we get lots more. So it's more energy efficient, but it's slower. And so that is non-ideal. Acid, that's interesting, Bradley. I wonder if acid's going to come back to us later on somewhere. So big things use more energy than small things. Citation needed. But there's all sorts of things here. One of them, you don't know what this guy is. Oh, we've got a tardigrade t-shirt in the back row, by the way.
Woo!
Give us a pose. Come on, let's have a look. Oh, bring that. Pint of Science, by the way, 2 sidebars to this. Pint of Science makes the best t-shirts. None of us work for Pint of Science, we're just volunteers doing this for the funsies. So your ticket money doesn't come to us, don't worry, we're not using it to buy drinks. But they do give us cool t-shirts when we do it. And that's kind of worth it. And it's really cool to see the past t-shirt years from Pint of Science returnees. Don't just say, I think it's Pint of Science t-shirt was the one that said that. I'm okay with it. Tardigrades rule, sometimes called water bears, is their kind of like common or lay name. Really, really little things. They live in water, hence the name water bear. They are so hard to kill. They're a type of what we call extremophile, or thing that likes extremes, thing that subsists, survives, or copes with extremes. The most famous example is they survive the hard vacuum of space. So if you completely stick them in a vacuum, where we would die very quickly, they just kind of desiccate away and hang out, and you bring them back to a normal atmosphere and they go, oh cool, and get on with their life, carry on. They can be dehydrated almost completely, and they just kind of harden up into a little shell, and then again rehydrate and they pop up and carry on. If you expose a person to the vacuum of space, they will pass out within 30, 40 seconds. You know when you're on an airplane and they say, put on your own mask first, then help the small, wee, innocent Irish lass next to you? They say that for a very specific reason. At the altitude the plane's at, the plane depressurizes. The air pressure outside, that's now inside, is so much lower that every time you breathe, you lose oxygen from your body. Oxygen flows out of you into the outside air. When deprived of oxygen, your brain just kind of shuts down, 30 to 40 seconds, and you die within 3 to 5 minutes. Now, again, citation needed, but if you're unconscious, you can't help the person next to you put on their mask, despite how helpless they actually are. There's probably a joke here about a helpless female I'm not going to make in front of a crowd.
Thinking that, yeah.
So, you put your mask on, this is just a public service announcement now, and then you survive, and then you help the unconscious person next to you, who's not dead but unconscious, and then they'll wake up, and then you save the day. Yep. Tardigrade just goes, what? Oh cool, and carries on with its life, because they just suck it up and survive. When they are doing that, when they're just hanging out doing nothing, they can take their metabolism, the amount of energy they're expending, down to 0.01% of their normal metabolism, or basically nothing. And that's a really extreme example, but the insects like crickets and such can do this to a degree as well. When they just hang out and look like this, just standing there, they're using fundamentally less energy, So one of the things I thought about Alien is in lots of the movies it spends a lot of time in the background just kind of watching. You're like, hang on a second, that thing could rip me apart, right? It just kind of hangs out like this, and then explodes and rips you apart. So I was thinking, at a much bigger form, maybe it's kind of like that. Shuts down metabolism when it doesn't need it, and then explodes in a kind of cloud of violence, death, and goo and acid blood. So maybe the best example is one of these guys. To take it to another gross animal. Don't ever get that close to either of these. But crocodiles and pythons are really big animals, not just, again, tiny microscopic tardigrades or even small insects. They're incredibly large animals that are really violent predators, but spend most of their life just sitting there like this. And you think, that's an interesting log, I'm going to kick it with my foot. When you do that, it explodes with a huge burst of anaerobically derived energy. Massive stores of it that's got hanging out for when it needs to strike. Does violence, does death, explodes like a biological bomb, takes you down, eats, feeds, and then hangs out and recovers. What's really cool about them is they have incredible capacity for anaerobic metabolism and incredible capacity to cope with the side effect of it, so they cope with that acidity that they're producing when they do that really well. On the biological trade-off that afterwards, they're a little bit useless. We've all kind of heard that story about a python feeding and not eating for a week, right? They'll just sit there and just lie there and digest and recover, to the point where they'll reform some of the morphology of their gut to better digest their food, and then afterwards undo it, I guess, unform, whatever the word would be. So you've got these really cool examples of these violent predators who can really manipulate these pathways. Not quite to the same degree, but can really do it. And by doing so, produce a huge dump of acid into their body. That's kind of cool. This is just a gross picture, which is not real. AI, spoiler, just citation. But the deeper point for this one I was thinking about is metabolism still. This idea of turning food that you're eating into mass for you. So when humans, when we eat food, when we eat hamburgers, when we drink too many calories, that kind of thing, I'm trying not to put you off your drinks because, this ship's supporting us, we should support them. But when we do that, it's about 20% or so efficient, among friends, rounding areas if there's any scientists in the room. So it takes about 5 kilograms of food, let's say, to give you a kilogram of mass. We're inefficient that way. We burn energy, we are warm-blooded, we lose heat like crazy. That's a positive and a negative. Insects can be almost 1 to 2. I think the number I've got written down that my researcher found for me, for credit, is 1.7 kilos of food for a kilo of mass. Now, if a kilo-sized insect comes on me, I'm going to scream quite loudly, but that's our ratio here. So if that's the reason why we look at insects for things like food production, for protein production, is producing proteins via chickens, via pigs, via cows. It's tasty and delicious, but relatively inefficient from a food source point of view. Feeding insects, grinding them up, sorry guys, into proteins that we can then eat that don't look like that is a really efficient way of turning feed into protein for us to eat. And that's where that idea comes from. And then maybe this thing is more insect-like than us. It's got a big shell, it's kind of hardy, I get that. So it looks kind of like a big insect. Maybe it's ectothermic, cold-blooded. Maybe it's doing something on that pathway, something like that. Anyone tried insect proteins? A couple? Yeah. Interesting.
That was tasty, yeah.
I didn't mind mine. What do you reckon?
You had the cricket flour.
Yeah.
Used, and it was no different to
Yeah.
something else. It was fairly bland and not a lot of...
Anyone tried full insects? Yeah, there we go. What do you think? Yeah. The shell's a bit crunchy, eh? And the back? Did you like it?
Like crisps?
Yeah.
Yeah.
It's all about the seasoning, right?
It's just the feeling before, you have to bite the head off and that's it.
That's what.
That's me.
Yeah. But we can start to put this together, right? We can start to put it together into a thing that's specialized at producing huge amounts of energy really quickly, that's maybe specialized at gaining mass from its prey when it does strike and it does go to town on them. And we can start to try and put this together a little bit. So I've just changed one thing now. Oh, there's way too many words on a slide, Bradley. But what we've got is this life cycle that we can start to put together. That I think what we've got is something hanging out in the neck that's doing nothing for extended periods of time. Just sitting there waiting for a trigger. A trigger being some idiot walking past, and it goes, ooh, I wonder if I can eat that. Pops open, I wonder if I can impregnate that, I guess. Pops open, wham, inject, implants. That thing grows inside of you. That thing violently comes out and then does its alien life cycle. After a period of like parasitic nutrient extraction, maybe it's sucking proteins from you, the host, maybe it's sucking energy from you, the host. Somewhat like human babies do, I guess. Rapid growth phase, and then maybe these kind of drone predator things that we know so famously with the aliens, they kind of hang out doing nothing. We call it quiescent, or just kind of really in a quiet place, ready to go. And then when they do hunt, they go, they turn on, they fire everything, and then they have to really settle down and recover. Otherwise, they just rampage to the ship and kill everyone in 5 minutes and be a crappy movie, right? Now, it still gives us the problem of the carrot. And the problem of the carrot is where does it still needs to get the mass from somewhere, right? It still needs to feed, it needs to eat something. This is not Photoshop. This is a giant weta. This is from my home country of New Zealand. It's the closest thing New Zealand has to an Australian style creature, or something that's out of your nightmares.
It's cute.
I don't worry about you.
Who's this?
A giant weta, the largest one ever recorded was 75 grams. For context, that's heavier than a tennis ball. This is a normal human being's hand. I've not changed in any way. When they eat, it's so loud, you can hear it. You know, it's go rah, 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 and you hear it crunch on that carrot. But it's consuming mass, and there's 2 or 3 things here. This is the biggest insect in terms of mass that we know of. There were some bigger ones in the past. There were some big dragonflies that were like, I think it was approaching 1 meter, 2 meters tall in the oldie dinosaur days when there was a lot more oxygen in the atmosphere. And the reason why is they have to absorb oxygen through holes in their shell. And so they can only be so big. They don't breathe in the same way we do. They don't have formed lungs like we do. And so our alien either is using some structure that we don't recognize as lungs, or it's absorbing oxygen like these things, which is problematic. Or it's anaerobically going to town on things. That's cool. And then I had to read around this again some more. And this thing happened that I didn't know about. Not a super fan. Super fan Kathy when it comes to this movie. Enthusiastic amateur. So thought about watching the movies yesterday to prep for this. Didn't. Did nothing instead. But apparently when they made the movie in 1979, they novelized it at the same time. They wrote a book about it and released the novel Alien. What's really cool about any book that accompanies the movie is it always has more details in it, right? So I went straight to the novelization that came out at the same time. There's a couple of things I found in this. Immediately, in the famous scene where they're sitting around, where our guy has survived, the alien facehugger, it's fallen off his face, and instead of doing quarantine, as we heard earlier, they decide to have lunch. Why would you not? Having just been sexually assaulted by an alien, you're like, let's have lunch together, boys. And in it, there's 2 things. One, they give him a medical scan, and the quote here is, his body functions continue normally, but there's fresh indication of tissue degeneracy and breakdown. He's losing tissue, he's losing muscle mass really quickly, which I take to mean that parasite is feeding off of him, right? That's the thing that parasites do all the time in nature. And then later on, when they're eating their lunch, Kane, the guy with the parasite, ate differently, wolfing down huge portions of artificial meats and vegetables. He'd already finished 2 normal helpings and was starting on his 3rd with no signs of slowing down. He's incredibly ravenous, he's incredibly hungry, which some parasites do to their host. They seek out food for their parasite, right, to help feed them. And then my favorite line of all, unmindful of the nearby display of human gluttony, Jones the cat ate delicately from a dish in the center of the table. Because the cat is the hero of the story.
Of course.
And then even later on in the book, when they're chasing this alien around the ship with their flamethrowers and trying to do their thing, there's this really cool quote the first time they pin it down in a room in the ship. And what room is it in? It's in the food stores. And it even says in the book, packages of every size were strewn around the floor, open in ways and means by the manufacturers had never envisioned, blah, blah, blah. Tins had been peeled apart like fruit. From what they could see, the alien hadn't left much intact. So they knew that. They couldn't put it in the movie, but they knew. They had to eat something, right? Because what happens next? What happens next? in this scene. Oh yes. Are you saying I should show the picture? Oh, thank you. Thank you. It's one of the great moments in cinema. So many good stories around this. The story goes they didn't tell the cast what was going to happen, so it popped out, and some of the screams were real because they're kind of horrific. And two kind of things here. This is our parasite bursting out for the first time. And when I told a friend I was doing this, he went on an extended rant about this scene just absolutely ridiculous. It's crap. And the thing he said was stupid is it burst through the chest, the rib cage, not through the soft, squishy underlayer in your abdomen. Why not go down and out, right? Easier route. And I was thinking about this for a long time because I genuinely thought, I don't know why, I always thought it kind of went down your esophagus into your stomach, but it seems to go down into your lung, which is much more common sense because it's an easier route. There's no dark acid that might damage its developing baby soft parasite tissue. So maybe it doesn't burst out to the rib. But then I thought about it some more. Because how strong is a rib, really, among friends? Because if it's hanging out inside your kind of thoracic cavity where your lungs are, it's got to get out through those ribs, right? And it can't it's a problem of physics. It's not a tiny little Bruce Lee with a 2-inch punch breaking a rib. It can't just go through one. So it probably has to chew its way out. Because it didn't hurt until it decided to come out, and then it was all sorts of pain. I don't know if you've ever had any broken bones or badly hurt bones, but bone pain is a horrific sort of a pain. As a human physiologist, let me tell you that. Bones aren't as strong as you think they are. They're strong in particular ways, the way they're designed to be stressed, but in other ways they're not. And there's a really cool example of this that I do when I do with school children, when I talk about biting off your own finger. Because among friends, close, I know not quite, but a fingers are almost the size of a rib, right? How much force would it take to bite through a finger, do you think? It's about the same amount of force it takes to bite through a carrot. So, if you ever wondered, could I bite my own finger off? It's not very hard. Let's go take a bite, sorry.
It's just refueling.
I didn't think that through.
See, this is why we didn't give you pizza.
So I wonder if it goes, okay, out time, pull something away, crunch, 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 out. And that's why it's so bloody and so painful and so awful. Chest burster, perfectly viable. Crocodiles bite, their force is incredible. So it's quite plausible, worryingly so. And even more, is this a plausible reproduction method for something in nature? Yes. Parasitic wasp, caterpillar. Yeah, it is. One of the things we talked about was most parasites don't outgrow their hosts. That's, again, a common sense problem of physics. And this was one of the best examples we could find of a parasite that was approaching the scale of its host. But when it was finished, when it used up its host, it was time to go. It was time to get out. These things change their host behavior. Some parasites make the host seek out environments that better suit them. There's one really cool one that it thinks about its future, that infects snails, and the snails crawl up grass and then cows eat them spontaneously, just by accident, and then it goes through the gut of the cow, and that's part of its reproductive cycle. There's ones that make them seek out shade and they crawl underneath leaves, and that's the best place for them to survive. There's the one that you'll just tell me the name and I've forgotten, that's the fear of cats.
Oh, toxoplasmosis.
Toxoplasmosis, which mice get, which takes away their fear of cats, which means they get eaten by the cat, which helps out the parasite's life cycle. By the way, that infects people, and we don't really know what it does to people. But some people don't mind the smell of cats, I'm just saying. There's no good evidence for that, by the way. It's probably just a good story, but it's a great story. So that's horrific. But again, that's the fundamental problem here, and this comes down to everything we know about biology. Parasites don't get bigger than their host. So that's a fundamental problem there. Even with extra mass, even if it was feeding like crazy, that's a really unusual adaptation in biology, to the point we've never seen it really. I guess the only example I can think of off the top of my head would be humans or other mammals, where male-born children often get bigger than their female parent, and fetuses in utero are basically parasites, let's be honest, but not fundamentally bigger. So that's that one. Tick. We'll call it a tie, shall we? Neither a win nor a loss. Acid blood.
Can I just go back to the nutrition bit?
Absolutely, go for it.
So this creature's in his lungs, and it makes him eat lots of food that goes through the stomach. So, and then he bursts out, so he doesn't get any profit of.
Oh, okay, yeah. I don't think it's, so in my interpretation of it, shall we say,
Yeah.
I don't think it's directly feeding the food that he's eating.
Right.
I think we eat food, we turn that into mass or energy, and he sucks energy from us. Sucks some of that ATP directly off us, or sucks amino acids straight out of us.
Right.
In terms of a realistic time frame, of course it's too quick.
Yeah.
Absolutely. And that's one of the big flaws here, it's the matter of time. Physics breaks down.
But
Yep.
you've also seen people who suffer from tapeworms and stuff become ravenously hungry because that stuff's being sucked out.
They actually don't become ravenously hungry. They actually just get a bit of a sweet tooth
Okay.
and crave carbs more than anything else. But it's kind of a myth that a tapeworm will actually cause you any sort of nutritional deficit. I'm not like pro tapeworm over here. Just yeah. So like if you have a tapeworm, you wouldn't even know you had it for the most part. It's only if you had a huge amount of them. And even then what's going to happen is like intestinal blockage, and that's what's going to cause you harm. But they don't actually increase your appetite a whole bunch. They just change what you're into and make you lean towards carbs.
You're saying I shouldn't have taken that tapeworm for weight loss. My Victorian guidelines were wrong.
No.
So this one was a interesting one. I promise I won't spend much time on them. That was the big one was the weight gain one. How do they function with acid for blood? And we argue about this a lot. We have two schools of thought on this one. One school of thought is they literally have highly acidic blood. And that seems to be the kind of the parlance of the movie. And in the aforementioned examples of anaerobic metabolism, our blood's pH does change a little bit. Now I'm talking really small amounts, microscopic, that's not even a measurement, Bradley, but incredibly tightly regulated amount. But we do have different pH or levels of acidity in our blood in different parts of our body, and during metabolism we can see changes in it. If it becomes too acidic, our blood, for example, cells stop working, proteins stop working, things start breaking down, which stops us from exercising, continuing that cause of that acidity, which is one of the ideas behind fatigue. And if some of my research friends in this area heard me say that, they'd get mad at me because I'm oversimplifying it a little bit. But we do have this regulation of our body, and we do regulate it really, really carefully. Now, who's seen Breaking Bad?
Woo.
So that's a topic switch, right? What the hell? There's a really famous scene in Breaking Bad where they're trying to dispose of a body. And there's the smart guy and the guy who doesn't listen. And the smart guy says, okay, I've got a couple of barrels of hydrofluoric acid, and I need you to go to hardware shop, American version of B&Q, and pick up a very particular type of plastic barrel. Put a body in that, pour the acid in, the acid will destroy the body. No harm, no foul, jobs are good in, right? Unfortunately, our man here doesn't listen. He goes, well, stupid plastic, what does it matter? Chucks the body in bath, pours acid over it. What happens next? It destroys the body, but it also destroys the bath and the floor underneath it, and causes chaos when it falls through the floor of the building. And the acid destroys everything. The kind of take-home point here, in a way that an actual biochemist will explain to you afterwards, because I'm just a simple physiologist, is not all acids break down all things in the same way. And some plastics are resistant to some acids. Some acids, or in our body, for example, in our stomach, we have really concentrated acid within our stomach that helps us digest and break down foods. But that doesn't break down our body. We protect ourselves against it. One of the ways we protect ourselves in the human stomach is we secrete, we have these special cells on the lining of our stomach that secretes this really thick mucus. Mucus is a fun word to say in front of people because they get grossed out by it. That mucus contains lots of bicarbonate, and that bicarbonate interacts with that acid. And there's two things. One, it neutralizes it, and two, that mucus layer actually stops the acidic stomach contents interacting with these living cells that would otherwise be burned and harmed by this acid. So we can protect ourselves. And you can imagine a situation where cells could either be have a lining that's protective, like some sort of biopolymer. We find biopolymers or plastic-like things that are made by biology and life in environments. Or we could have some sort of coating on top of our blood vessels that protect us from this acidic blood. Or we could have quite fast turnover. And interestingly enough, cells in our gut turn over very, very quickly because they're constantly stressed out by this environment they find themselves in. There's a couple of ways we can cope with this. The other example of an idea we had, to throw it out there, was that maybe it's not blood per se, maybe just some dumb space miner said, oh, it's bleeding, because liquid's being dripped out of it when we heard it. Maybe it's like a toxin or a poison in a snake or other animals where they store it in a repository, like, for example, a snake's toxin stored in glands next to its mouth, so when it bites, it can inject it into you. But that toxin would also hurt the snake if it was to leak out, for example. So maybe it's stored in specialist glands, and those glands just happen to be everywhere. I think you can see which side of the argument I fell upon when we discussed this idea. But that's an option too, right? Maybe it's some special defense adaptation. If injured, it injures you back. Probably quite a successful one, if you think of it that way. So, we sat down, we looked at it, and then my colleague here, Kathy,
Yes.
said, I know how they did that. This is literally the scene from the movie where they melted steel on camera. And she went, that's really easy to do actually. So what we've done is we wanted to give you a go at melting steel with acid blood from aliens. So what we prepared for you for funsies is some high-tech steel.
This is in no way polystyrene.
It's space steel, all right? It's futuristic.
Yeah.
And we also prepared for you some,
Yeah.
some of our aforementioned
Incredibly
alien blood.
flammable.
Yes. And we actually genuinely want to say out loud, this is actually flammable, it is actually bad for you, please don't get it in your drink, or your eye, or your mouth, and it will stain your clothes, and it will damage plastic. So we've got some of our space alien blood-proof plastic trays, which everything's going to be done inside of tonight. We've got some space steel, and we've got some acid blood. And we've got about 4 or 5 of these.
Yeah, there's 2 over here and there's 2 over here. So we'll put someone in charge.
Yeah. And on the aforementioned caveats of not getting it in your mouth or your eye and not smoking in this room, do feel free to drip a small amount of alien blood on your steel and see what happens next. Just a bit of a dribble should do it. Oh yes, there we go. This man knows what it's about immediately.
Go for it. Oh, get the video.
I love this. Immediately. Can we film it? It shouldn't take much at all. This is not at all stalling for the next teacher running slightly late. I'm glad you understand. Don't tell anyone. What's that? Is it doing free pizza? No, I don't know. Don't find out. Please don't find out. I find the business is going to think you can find out.
Yeah.
Yeah? So, we'll steal them back. Steal them back. No, actually steal them back. Steal all the trays back when they're done. Thanks. Unfortunately, when you're done melting, I do have to steal the trays and everything back from you. I promised I would. Oh, you guys went to town on yours. Jesus.
Yes, that's a big alien.
That's a rough thing.
No, just put this next to the windows and start the reason.
You owe me one more. We had 4, I think.
Alien blood? Yeah. See? Hashtag not all acid.
Now,
If it goes through the conference,
Now remind me, Kathy,
Yeah?
when you first thought this,
Yeah?
didn't you like write to someone at the movie or something to ask?
I tweeted it to Ridley Scott.
You asked Ridley, you tweeted Ridley Scott and said, is this how you did it?
And he never told me. I never heard. I know, right? It's almost as if he doesn't want his awesome secrets revealed. But they have been nice.
So if you were to be realistic and tell the truth about this, what we have here, just for funsies, for future reference, or if you're going to do a demonstration for kids later on to show them, it's just run-of-the-mill polystyrene we stole from containers in our labs, just lids of boxes. You may have painted them grey. We had to go back and forth on paint for a while because some paints, especially spray paints, contain something called acetone, because our alien blood is just acetone or nail polish remover, with a couple of drops of the most fluorescent,
Yeah.
just died live on stage there, fluorescent paint we could find to give us the alien blood effect. And when we made it, honestly, we did in the lab, that's actually bang on point. It's actually exactly the same. We're really pleased with it. Polystyrene is just lots of little air bubbles surrounded by
Polymers?
What the plastic around it, the polystyrene.
Polystyrene. It's like
Literally.
styrene, but lots of it.
Does this for a living. Cool. Literally do this for a living. And so what you've got basically is just a bunch of air trapped in little tiny bubbles. Yes, acetone breaks down that polystyrene, releases it, and gives us a really cool melting effect. We were really worried that the paint would make a protective layer on top of our space steel, polystyrene. So we practiced a lot in the lab and had fun melting stuff. And actually found some containers that we thought were polystyrene but weren't. They didn't melt at all and put acetone on it. So it just, again, hashtag not all acids, right? In this case, not all
Acetones.
acetones. Very cool. So that's 3 of the 4, you know? Lastly, from a movie that was never made, because remember, they only made Alien and Aliens and no more, and Disney definitely never bought it, but from a movie that was never made, what is their problem? Why are they so goddamn aggressive, you know? And this one was actually really easy. Really, really easy. Do you want to see some cute animals?
Yes.
Yes. Let's start at the top. This shrew is the smallest mammal that we know of. So it weighs about 25 grams. Now for context, that's a third of that giant weta insect I showed you earlier. That's how small it is. Has incredibly fast heart rate in the thousands of beats per minute, as opposed to our kind of 50 to 60 if you're healthy and 100 if you're not kind of moment. Hummingbird, again, bonkers fast heart rate. Again, bonkers cute, right? And then, obviously incredibly cute animal, the honey badger. Now, all 3 of these animals have 2 or 3 things in common. Any guesses what they are?
They're cute.
Yeah.
They are bonkers cute. I'll give you that for freebie.
They're quite aggressive.
They are bonkers aggressive. This little guy is crazy aggressive. He will, what'd you say earlier? Ovary up
Yeah.
to another shrew and go to town defending his territory. He is incredibly territorial, incredibly aggressive, and will have at you if you're a 25 gram shrew. Hummingbirds, crazy, crazy aggressive to other hummingbirds. To slightly bigger birds as well, they will go at you. They defend their crop, their land, their bit. Honey badger is the definition of an aggressive animal. They've been known to take on lions, they will take on anything. They're actually really crazy smart. One of them was really famous for being an escape artist and would get out of any enclosure. They dig, they hunt, they chase, they're really solitary. They are just all not happy people from how we see it. You know what I mean? They are fighters. They all also have really high metabolisms. They all burn fast and hot. They run hot, they consume resources like crazy, and so they're aggressive to protect them. Which I think kind of rings true for our alien friend, right? It needs a huge amount of energy, like we just kind of covered. It's got to get it wherever it can, but it runs fast and hot. So the downside of that is I think our alien runs hot, metabolically speaking, not necessarily warm-blooded, but in doing so, it has a really short lifespan. It probably doesn't last very long. And again, it comes back to that ethos idea in the movie. You drop one on the world, it eats everything, and then dies out from starvation, and then you're done. You've got this world, this biological weapon works for you. So that's horrific, especially for cute little things like that shrew. Isn't it awesome? And this kind of behavior is all over the gaff in nature. So as an example of that, all across the animal kingdom, high metabolisms associate with a need for resource and thus aggression to protect them. Because if you need a large amount of resource, but you're like, let's try diplomacy, let's talk this through. You don't tend to do very well if another animal comes along and says, let's eat you. It's got its resource, you don't. It's a sad statement of human affairs, that one, isn't it, when you take a parallel too far. In our bees we had before, aggressive bees activate their metabolism in a different way, which provides them more energy to do battle with those other bees they're doing battle with, or whatever's attacking their hive right now. So they just switch on faster metabolic pathways. They get energy quicker, but they get more aggressive for it. And if you mess with them in the lab, molecularly speaking, you turn on and turn off different pathways, you can make them more or less aggressive. And the way they measure that, by the way, which is awesome, you've got two bees in a cage and you measure how many times one bee walks up and kind of goes at the other bee, thrusts at it if you will. You measure aggressive movements. And then humans, of course, because testosterone in humans does lots of things. It lets men grow big and strong, that classic masculinization hormone. It's found in men and women, by the way, just in different concentrations massively. Testosterone in men helps build muscle mass, drives our metabolism, turns it up slightly, but also drives aggression in men. Who knew? Also pretty. So throughout the animal kingdom, you find these links between metabolism and aggressive behavior. And so I think that kind of explains if we've got a creature that needs to grow really, really quickly and hunt resources to do it, as a byproduct of that, it's not a happy camper, you know? It's going after you. So, I've talked for too long, and actually I have talked for a bit longer than that. Apologies for that. But, within the rules of biology, within the rules as we understand them, it takes a few backflips here and there, it takes a little bending here and there, especially the physics and maths problem. But it's not an impossibility. It fits some of the models we've got. And in fact, that often happens in things like science fiction. We take a thing and we say, what's next? Or what if we change one thing? And this is an example of that happens all the time. What would be just slight twist on what we know, you know? And it's a really cool example of that. And it's a really cool way of linking this. If you're curious, well, it's a really cool way of getting a room of, say, kids involved in science and saying, okay, here's a cool movie of saying, how would that work? And this is a twist I like to do in these talks. The queen idea works really, really well, to the point where I genuinely think that that's where they got inspiration from. The idea of a breeding queen and drone workers underneath of it. I honestly think it was that way around. I've never bothered to look it up, but it'd be a cool idea, wouldn't it? Run fast and hot, live short. And as a side product of that, that gives us that necessarily aggressive creature that we have. And that is why I think aliens is a really cool way of teaching basic biology and human files. Thank you very much.